Galois theory, which was first invented and developed by Évariste Galois, is our main tool to study solutions of algebraic equations. And more generally, it's an amazing tool, an amazing theorem that relates subfields. So if you have a field extension, those fields that are in between, and a group that we now call the Galois group, which in fact classifies all the intermediary field extensions within a given Galois extension. For example, let zeta be a seventh root of unity. So zeta is e to the 2 pi I divided by 7, which is a root of x to the 7 minus 1 equals 0. So this is a number whose seventh power equals 1. Then we can actually express all the roots of this polynomial in terms of zeta, because, well, there are 7 roots of this polynomial over the complex numbers, and those are 1, zeta, zeta squared, up to zeta to the 6. And now it's natural to be interested in the extension that we get from Q when we adjoin zeta. So this field, Q adjoin zeta, is the smallest field that contains all of the rational numbers and zeta. So this field contains all the roots of that polynomial, because this is a field, so it contains all the powers of zeta. So all the roots of x to the 7 minus 1 are in this field. And in fact, this is the smallest field that contains all the roots. So what field is this, and what is in between? What other fields are there contained strictly in between these two fields? Since this contains all the roots of x to the 7 minus 1, this is a splitting field, and therefore it is Galois over Q, and therefore Galois theory tells me that any field that is strictly in between, so containing here and containing Q, is in correspondence with some subgroup H of the Galois group of this extension. So what is the Galois group, and what possibilities are there for H? It turns out that the Galois group in this case is isomorphic to the units in Z mod 7, which in turn is isomorphic to Z mod 6. Z mod 6 has exactly 3 subgroups. It has the multiples of 2, it has the multiples of 3, and it has the 0 subgroup. The smallest subgroup, so the trivial subgroup, corresponds to the largest extension, while the largest subgroup, so the entire Galois group, corresponds to the smallest extension, which is just Q itself. So the question is, what about these two groups? They correspond to some extensions of Q in between these two fields. So what are those extensions? And using Galois theory, one can compute that there are two, a quadratic extension generated by the square root of minus 7, and a cubic extension generated by the cosine of 2 pi over 7.